Welcome to tonight's video on Class 2. We're going to continue talking about exponential functions and now get into how to tell if an exponential function is a growth or decay exponential function. First thing, the exponential form is when you have f of x equals a times b to the x. B cannot equal 0 or 1 because if it's 0 or 1 to a power, it's just going to be 0 or 1 as your answer, and it won't be an exponential curve. It won't go up. And A cannot equal 0 because 0 times anything will just give you 0. A is called the initial value of x. Basically, that means it's the value of the function when x is equal to 0. And that's also the y-intercept. Because if I put 0 in for x, remember anything to the 0 power is 1, so it just gives you a. So that's the initial value or the y-intercept. B is what's called the base of the function. That is what you're raising to the power. So now talking about how to change into exponential form. Well, this is an exponential form because remember, exponential form is a times b to the x. So here your a is 2 and your b, the base, is 5. The second one is not an exponential form yet because the exponent's x plus 1, not x. But remember, when we're dealing with exponents and we have like 2 squared times 2 to the third, we add the exponents. But we can also do the reverse. If we're adding the exponents, we can make it a multiplication problem. So in this case, it's 2 times 5 to the x times 5 to the first. And that's the same as 2 times 5 to the x, because 5 to the first is 5. And 2 times 5 is 10. So there it's an exponential form. Your a is equal to 10, and your b is equal to 5. This next one is a subtraction problem. You can make it 2 times 5 to the x times 5 to the negative first. 5 to the negative first, remember, is 1/5. And 2 times 1/5 is 2/5. So now your a is equal to 2/5, and your b is still equal to 5. For the bottom one, if you rearrange it, you have 2 times 5 to the negative x plus 1. You can take out the negative sign like that. So this is really 2 times 5 to the negative first to the x minus 1. Well, 5 to the negative first is 1/5. So that's 2 times 1/5 to the x times 1/5 to the negative first. 1/5 to the negative first, the reciprocal is just 5, so 2 times 5 times 1/5 to the x. And 2 times 5 is 10. So therefore, a is equal to 1/5, a is equal to 10, and b is equal to 1/5. All right, the reason why it's important to do this is because eventually this will help us to determine if it's exponential growth or decay. Without using a calculator, we're going to do these problems and remember that whenever it's a fractional exponent, the top one stands for the power or the exponent. The bottom one stands for the root. So, for example, if I had x to the 3/2, that means it's the square root of x to the third. Well, when I do f to the negative second, I get negative 3 times 2 to the negative second. 2 to the negative second is 1/4, so that's equal to negative 3/4. For the 3/2, 2 to the 3/2, remember, can be written as the square root of 2 to the third. Well, 2 to the third is 8, so the square root of 8 can be reduced to 2 square root 2, and negative 3 times 2 is negative 6 square root 2. So now an exponential function is called an exponential growth function if the a term is greater than 0 and the b term is greater than 1. So for example, if f of x equals 3 times 2 to the x, that is a growth function. It's a decay function if a is greater than 0 and b is between 0 and 1. So basically it's a fraction between 0 and 1. Like for example, if f of x equals 5 times 1/2 x, that is a exponential decay function. So what determines growth and decay? It is the base. The base determines if the function is increasing or decreasing. This one would be increasing if you graph it on your calculator, and this one would be decreasing if you graph it on your calculator. B is called the exponential growth or decay factor. So the top one here would be growing by a factor of 2, and the bottom one would be decaying by a factor of 1/2. So this next one, the first thing we're going to do is write the function in exponential form. So notice we have 1/3 times 2, factor out the negative 2, so we get x minus 3/2. And then remember, this is the same as saying 2 to the negative second to the x minus 3/2. And then 2 to the negative second is 1/4, x to the minus 3/2, and then we can split it up. So we have 1/4 to the x times 1/4 to the negative 3/2. Now remember, 1/4 to the negative 3/2, that is the same. Remember, negative means you're going to just take the reciprocal, so it's the same as 4 to the 3/2. So if I did that, I would take the square root of 4 to the third, and 4 to the third is 64, so the square root of 64 is 8. So it's 1/3 times 8 times 1/4 x. And this gives us 8/3 times 1/4 x. So now the question says determine if it's exponential growth or decay. Well, a is greater than 0, so it's either going to be growth or decay. But b is 1/4, which means it's less than 1, so therefore it's exponential decay. Because a is greater than 0 and b is between 0 and 1, and the decay factor is 1/4. So now we're going to do what we were doing last time with transformations on this exponential function. And the difference here is, notice the base is not e, the base is 2. So this one, we don't have to put it in exponential form, and it's actually better if we don't, because this will allow us to see the transformations. So first, the base function. Well, the base is 2, so it's f of x equals 2 to the x, which means that the graph is going to look the same as e to the x. The only difference is you'll have 0, 1, and then you'll have 1, 2 as a point, as opposed to 1e, and you'll still have a horizontal asymptote at y equals 0. So it looks like that. That's your base function graph. Now, in the correct form, this means to factor out the negative 2 in front of the x. So we did that in the previous problem because this function's the same. And then listing the transformations. So we have a horizontal shrink by 1/2 because of the 2. We have a reflection over the y-axis because of the negative sign in front of the 2. We have a horizontal shift to the right 3/2. We have a vertical stretch, or sorry, vertical shrink because of the 1/3 in front of the 2. Remember, anytime it's vertical, it's exactly what you think, whereas horizontal is always the reciprocal or opposite. There is no negative sign in front of the 1/3, and there is no vertical shift. There's no +1 or anything outside. So now we can make a chart. So we have 1/2 x, negative x, x plus 3/2, and 1/3 y. And our points are 0, 1, 1, 2, and the horizontal asymptote y equals 0. Well, 0 times 1/2 is still 0, negative 0 is 0, plus 3/2 is 3/2 1, and times 1/3 is 3/2 negative 1/3. 1/2 of 1 is 1/2. Then you have negative 1/2. Negative 1/2 plus 3/2 gives us positive 1. And then 2 times 1/3 is 2/3. And then for this, remember, since these are done to the x, it's not going to affect y equals 0. And 1/3 times 0 is still 0. So that is your horizontal asymptote. So now we're going to sketch the graph. So 3/2 and negative 1/3. So 3/2 is halfway between there, and negative 1/3 is, actually, sorry, it should be positive 1/3. I don't know where I got negative from. Positive 1/3 is right here. 1 and 2/3. So here's 1 and 2/3 would be almost there. Almost there. Y equals 0 is the asymptote here. So notice some people ask, well, which direction? Remember, it's going to be either a J curve or an L curve like that. And the way you tell is notice that this point here is above that one. So you know it's going to go up this way and then down towards the asymptote there. And it makes sense because if you notice, you're taking a reflection over the y. So normally it's a J curve, but when you reflect it over the y, this goes that way, and then this will come over here. And that's why it is actually decreasing. And also remember that when we did this originally, because this is the same function as the last one, we got that it was a decay function. Decay functions always decrease from left to right. All right, I hope this helps, and I hope you have a good evening, and I will see you tomorrow in class.